Lights, camera, action.
So let's put a little bit of chemistry into ecology. So what is pH? Well, pH stands for potential of hydrogen. I know most of you probably haven't gone into the full general chemistry yet, but at least you probably should know what hydrogen is, I guess. So basically what this method measures is how acidic or how basic and substance is, and we'll go to that right away. So in a pH scale, we have from 0 to 14. 0 being acidic and 14 being basic. Acidic is generally it's generally a sour substance. Like if you think of a lemon, if you think of like an orange, they tend to be on this side. Basic, on the other hand, tends to be more bitter substance. Like if you ever tried dish detergent, which I hope you haven't, this will be around the 14 area. So how does this apply to soils?
I would never eat dish detergent.
Okay. Soils also have a pH, and that is very important, especially considering that plants require a certain amount of pH in order to actually grow. So we have acidic and basic pH soils, and these are found throughout the world, but there are some common characteristics for them. For instance, generally acid-based soils tend to be found in more wetter areas, while basic ones tend to be found more in the desert. And actually, in this case, we're going to call basic alkaline, and this is how you spell alkaline. So what makes a soil acidic and basic? Well, for acidic, there's many different types of ways you can make it acidic. One of the biggest ones is through acidic rain, and this is for acids. This is for acids. So acidic rain is when basically, rain is not just carrying water, but in this case, it's going to be carrying some specific elements that, for instance, aluminum, which will generally, if added into the environment, will make the environment more acidic. And this is one of the leading causes of why some places get acidic. And it's also one of the biggest ways humans impact the environment. Another way that acids are added into the system is through plant respiration. So we know that plants release oxygen into the atmosphere, but what they also release is this thing called carbonic acid. And acid is already in the name, so you see why plant respiration will add more acids into the environment. And I hope you guys remember nitrogen cycles from, what was it, weeks ago? Something like that?
Day 2, I think.
Day 2, okay, thank you, Aditi. So, most of you guys probably, hopefully most of you guys remember ammonia from the midterms. So, through the process of ammonification, ammonia and ammonium are added into the soil system. And these elements, because they have H in them, they make the system more acidic. So generally, if you see like an element that's more likely to have an H in it, well, 9 out of 10 times they'll make the system more acidic. Now, let's go on to how some acidic systems can be very, actually no, there's one more part where,
You guys are still here?
I missed you.
hello, okay. There are other ways that our system can be acidic as well. And this time we're gonna focus more on man-made content. So, one way that systems turn to be acidic is, generally elements have like this charge on them. Like for instance, hydrogen would have a plus charge, calcium would have a 2 charge. This is not really important right now, but it's interesting to consider through a process called oxidization. Charges are being pushed to the other elements, which makes them more electronegative, which makes them more acidic. And this can be formed in many ways. First, number one way is mining. Because when we extract a lot of like minerals from the soil, we tend to tend to remove a lot of these more basic elements. And what this does is actually turns the soil more acidic. Because in fact, another way to think about it is you're turning over a bunch of the other elements that are usually found deep in the soil, and by overturning it, you make the soil more acidic. Now, okay.
Alright, I'm gonna walk by you.
Hi, Misty.
Bye, Misty. Okay. Weathering. In fact, weathering is also another way how acidic elements get into the soil. Now, let's just say this is just a rock in the middle of Arizona. Let's just call it a diep.
Hey, what the heck?
And okay, when you weather the rock, all of these minerals that contain these elements like calcium, sodium, and stuff like that fall to the ground. And these, through process of sedimentation, they become part of the ground. And because we kind of show that through oxidation, these elements will make the ground more acidic. Therefore, through weathering, you can actually turn the ground acidic. Now, okay, this was kind of long, but it's okay, because now we're going to basic soils and how do they usually form. There are generally two big ways they can form. So for instance, there are some certain minerals that when you weather them, they can actually make the soil more basic. Now, there are only certain ones, and the biggest one is called silicate, which contains the element silicon. And silicon generally has a negative charge. So if you think of, if you add negative charges into the soil, the hydrogen plus will react to it, and therefore it will remove this generally acidic part and make it more basic. So, and another way this can happen is also through irrigation, because through water because irrigation technically takes water from rivers, and rivers technically get their minerals from the mountains, and this is where all the weathering of minerals take place. So in this case, it's just another addition to this part of the cycle. Okay, moving on to effects. Now, fertilizers are generally acidic, and that's usually a good thing, because we want to make sure that our soil is at a certain pH in which plants can go in. But if it's too acidic, there could be some major problems. There are certain elements that I'm going to point out that's really soluble in very acidic environments, and this could be a bad thing for plants. So one of these elements, which I referred back before, is aluminum. Now, aluminum is generally a good element. If you have a little of those here and there, it should be fine. But if there's too much of aluminum, and this happens during an acidic environment, we can get something called aluminum toxicity. And this is not really good for plants, especially not good for plants. So here's a diagram of a tree and its beautiful roots. What aluminum does is it inhibits the growth of these roots, so the plant dies. Same thing for another element called manganese. Manganese, on the other hand, let's just say this tree has some sort of leaves here and there. I know these aren't perfect drawings, but they're better than these. I know. Okay, so yeah. What manganese does is it kills off the leaves. So in this case, it's also not a good thing in plants. And manganese, like aluminum, work best in an acidic environment. Now the question is, oh, maybe we should go for a more basic environment. Well, the problem with a basic environment is that it doesn't have all the macromolecules that we can see in an acidic environment. Like, if you think about it, fertilizers generally contain nitrogen and phosphorus, two of the most important macromolecules, components of macromolecules to be precise, for plants and animals alike. If you're in a basic ones, these are not likely to appear. Great, because they don't have a lot of soils. And another bad thing about basic environments in general is that they tend to not be good at preserving water. And you know, water is one of the most important components to life. I don't know why I drew this line. I'm just going to erase it. Okay, in general, a way to solve this is generally you need to find the good pH balance between acidity and basic. And one of the best ways to do this is with earthworms. Okay, I think this is a good earthworm. I'm pretty.
Do not name that earthworm meat.
Okay, there was a technical difficulty. So okay, Arditi does not want this earthworm to be named, so it's he who must not be named. Okay, So, earthworms, as you know, are very good for the soil. But why is that? Well, when an earthworm consumes the things it eats, it poops. Duh. But unlike what poops like from other animals and stuff like that, which generally contain a lot of nitrogen and phosphorus, which you remember makes the soil more acidic, earthworms poops can go both ways. It can actually make the soil more basic and soil more acidic. In a way, it's like a balance. And what is really cool about earthworms in general is that they can survive in almost any kind of environment. And so in general, the lesson is find the balance between soils, pH, and hopefully you remember something from this video, because I remember nothing.
You done? No, that was